The question is x plus equals to x plus 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 3 minus plus plus x, right? Okay, yeah, okay. So see, assignment operator will be executed in the end. Now let's use a table. The initial value of x is 3. So this is a postfix or increment operator. So 3 will be the value used, but 3 will be changed to 4 after using. Plus 3 minus. Now first the value of x is increased to 5 and then it is used here. Okay. So this gives x plus equals to 6 minus 5, which is 1. Okay. Now the assignment operator will be used. So this operator will give x is equal to x plus 1. X value, final value is 5 currently. So 5 plus 1, 6. I hope it is clear to everyone. If there's any doubt in anyone's mind, then you can ask it here and here itself. The reason is that assignment operators have very low precedence. Just try one more. Int x comma y comma z, x is equal to 0, y is equal to 1, then x is equal to y equals to z equals to 8. Printf %d %d comma x comma y comma z. Yeah, please tell me the output of this program. I'll show you the picture for a little help. Yeah, just look at the associativity of assignment operators. It's right to left, not left to right. This question is meant to draw your attention to this property, this important property. So associativity of if multiple assignment operators are there, then the associativity is right to left, not left to right. Yeah, I'll clarify it a little bit. See, there are 3 assignment operators present here. So the way the manner in which they will be executed will be right to left. So first of all, this will be executed. So z equals to 8. So z equals to 8. Then y equals to z. So y equals to z and z is equal to 8. So y is equal to 8. And then x equals to y. So since y is equal to 8, therefore x is equal to 8. So the answer is 8, 8 and 8. Okay. It is a format specifier. Okay. What it does is while printing, this is the printf function. So this function, when it tries to print, the compiler has to know what is the data type of the variables that are going to be printed. See, these are the variables which we are printing, x, y, and z. Okay. So %d is a format specifier for integer data type. So it tells the printf function before it's printing that the number that the variable that you're going to encounter is an integer type. So the first x is integer, y is integer, and the third %d is for z. So z is also integer. For float data type, we have %f. For character data type, we have %c. Similarly, we have format specifiers for every data type. I hope it is clear. They are called format specifiers. They specify the data type. Yes, we use it when we are printing. Yeah. It's one of the requirements of the C compiler. Okay. Now we'll come to a very important part, which is conditional statements. See, computers are expected to be smart devices, at least a little bit smart. So the smartness comes mostly from conditional statements, or actually the smartness of a program, because there the statements which are conditional means they will be see, normally till now the programs that we have written, for example, we have written 4 lines of code. Once you run the program, all the lines will be executed. But if some of these are conditional statements, this means that there is a condition and these statements will be executed only if that condition is true. Okay, this is the meaning of conditional statements. They are executed only if the condition is true. What are some conditional statements? The main conditional statement that we'll be reading is if else and switch case. Those of you who have been exposed to any level of programming or at any level, you must have heard at least the name of if else. Anyways, we are going to study about it. So these are the two conditional statements that we'll be reading about it. And the execution depends upon the condition. Okay, just to show you a syntax for if is very clear, and you must be noticing that the word if else, it's all taken from the English. If, then there's a condition, then there's a statement block. Okay, sorry, I should not draw like this. I have a habit. It's basically a curly bracket. Okay, see, a block means whenever you put 4-5 lines in a block, this means that for compiler all these are considered one statement. So because after this condition is true, then the compiler will only execute the next statement. Now if you want 3-4 statements or instructions to be executed, you need to put them in the block so that the compiler will know that okay, all these are one together, one unit, and if this condition is true, all of them have to be executed. Instead, if you write like this, if condition, and you write them without the block, okay, first, second, third, fourth, even if you have given space from here, the space doesn't mean anything for the compiler. So this condition is true, then this will get executed, and all these other are not the conditional statements, so they will be executed even if the condition is false. Okay, that is why this block is necessary. But if you have only one statement, you don't need to give the block, you can directly write it. Okay, we'll do more examples of this. Okay, now if else का क्या मतलब होता है? See, if condition 1 else, so if this condition 1 is true, for example, if x is greater than 5, so if x is actually greater than 5, then this line will be executed. And else means if it is not true. In the case of these statements are not true, else का English meaning भी यही होता है, else. Of course we know the English meaning. So then this statement will be executed. Then there is if else if is there. So let's just see what is else if meaning. For example, if I write one block here, okay, maybe I'll show you. Yes, so you can see else if is there. Else if means you can again join one more condition here, and those statements will get executed if this condition is true. Okay, so if this condition is true, then these statements will get executed. If this is true, then these, and if none of these is true, else these will be executed. So it's not necessary that you need to use everything. You can only write an if statement, or you can write if with else, and you can write only if and else if. And nested if, nested in programming means when something is repeated within its own framework. For example, there is an if and within the if. Do you see this unit? So this is an example of nested. These brackets are here. Okay, so this is an example of nested if. For those who feel overwhelmed, don't feel overwhelmed. We'll do proper examples and then you will understand it properly. This is just to explain to you the syntax. Okay, write a program. Okay, I'm using the short form for write a program to enter 3 numbers and print the biggest number. And by enter I mean your program should take input from the user and then it should print the biggest number. You have to use if else in this question. Yeah, I'll show you one example, don't worry, and then you can continue with the next questions. I'm not writing void main and all. I hope you guys understand that that is not required to write now. Okay, so basically first I created the guys who I want who were finding if you want to try it on your own, you continue. If you want to look here, you just look here. Okay, first I created 3 variables a, b and c. Then I want to take input from user, so I need to give some statement to the user. I tell him enter 3 numbers. I could have written enter 3 integer numbers. It's okay. For now, we are working with integer. Then I'll use scanf statement. Scanf percentage d, percentage d, percentage d, and a, and b, and c. Okay. Now I'll start with my if part. See, if a is greater than b, I'm doing the very simplest version. Okay, and then I'll tell you how we could optimize the program. Okay, this is the first basic version. If a is greater than b, first see, whenever you're writing a program, make it a point to think that the computer tries to imitate humans. If you were given three numbers, how would you try to do it? You first compare two numbers, and if one of them is bigger, then you compare that number with the third number, right? So similarly, we'll do it here. If a is greater than b, now assume if a was greater than b, then you would like to put a nested if, then and you would like to check if a is greater than c also. Now, if a is greater than c, then we would print greatest number is percentage d a. Sorry, I wrote x. It's a. Now, if this, we can do this if. Now, see, if a is great, this all is, yeah. So this everything is coming under this block. Okay. So if a is already greater than b, now if a is greater than c, then a is the greatest number. Else, if c is greater than a, then we print that the greatest number is percentage d c. Okay. Now many of you can tell me that instead of else if, we could have written else here. Yes, we could have, but assume that all the three numbers are same. Then it will print the greatest number is c, even if the greatest number is not c. Okay. So taking that into consideration, I've written this, but it is a common practice that you can replace this only with an else. Now this was one block of thing that was executed. Now if this isn't true, a is not greater than b, else, or to be more accurate, else if b is greater than a. Okay. Now if b is greater than c, then we print that greatest number is percentage d b. Else if c is greater than b, see, b is already greater than a in this loop, in this block. So if b is not greater than c, this means c is greater than b. So then we print that the greatest number is percentage d c. Okay, and we close this block. See, this block that was opened, we close it. And what can be a third possibility? The third possibility that is possible is that the user can enter all a, b, and c equal. If a is equal to b is equal to c. Okay. No, sorry, we can't write it like this. My bad. And b is double equal to c. Then we can print that don't try to be over smart. Okay. Yeah, now we'll see how we can optimize this program. This as well as this true. So if you put a logical and here, then it works better because these are logical operators. So we want that when this as well as this is true, then this entire statement should be true. Okay, because this is valid only if a, b, and c all are equal. If a is 5, b is 5, and c is 6, then we have a greatest number which is 6. Okay. Okay. See here, I have not used print statement. Do you guys notice that in this program I have not used print statement everywhere? What I have done is I have created another variable big equals to 0, and whenever I think that okay, a is big, a is the biggest, I mean, so I have stored it in the variable big. So whichever statement gets executed, the big variable will always have the biggest number, and in the end I'm printing this variable big. So that saves me from printing 4 times. Okay. This is just to explain to you that we can always, there's a scope for optimizing the program. Okay. Instead of doing this nested if loop, okay, till here, we can write it in one line only. Let me show you how we can do this. Let me show you the output of this program first. Enter 3 numbers. Let's enter 5, 3, and 8. Biggest number is 8. Now, going on it like this. If A is greater than B and A is greater than C, then we would have print, instead of print, we could use big is equal to A. Else, if, sorry, B is greater than A and B is greater than C, big is equal to B. You could have also written else here. Okay. In fact, you can do, because if all of the variables are same, then the biggest number is any number. Okay. If you don't have to tell which variable is biggest, then you can do like this. Else big is equal to C. Okay. So this is also one way, and then you can print big. So for every variable, now here we are using logical operators. For any one of you who is not able to recall, this is the output of this logical operation will be true or false. For example, if A is 5, B is 3, and C is 8. So 5 greater than 3, this is true. And A greater than C, 5 greater than 8, it's false. And since it is an AND gate, all the inputs should be true to give true output. So this entire thing becomes false, and therefore this statement is not executed. Okay. Similarly, this is not executed, and therefore we come into the else, and big is equal to C. Okay. I hope it is clear to everyone. Now you guys can attempt another program. You also learned how a ternary operator could do it in a very simpler way. Just attempt this program, write a program to enter 3 sides of a triangle and check whether it's a valid triangle. Sorry for the bad handwriting. Write a program to enter 3 sides of a triangle and check whether it's a valid triangle. Guys, you can, taking the attempt is required to promote original thinking. Otherwise, you will only think the way I attempted. Okay. There can be several ways. I'm just doing it from a simple way. You can take inputs in A, B, C, big value less than some of the other values. Okay. Actually, the condition is that sum of any two sides should be greater. A plus C should also be greater than B. C plus A should also be greater than, okay, sorry, that's already written. And C plus B should also be greater than A. So we need to verify all these are true. ABC, then we'll write a scanf statement. I'm not writing it again, but you know, guys, how to do this. Percentage D, percentage D, percentage D, and A, and B, and C. So you'll get an input. Now, A plus B is greater than C, and A plus C is greater than B, and B plus C is greater than A. If these are true together, then we can printf it's a valid triangle. I'm just writing the short form of triangle, but in your keyboard I don't think you'll find this. Else printf invalid. Okay, just take a moment to absorb it. If you guys have any doubt, You can attempt this question that, write a program to enter marks in 5 subjects. For example, a student's marks of 5 subjects are there. You have to enter those, you have to take those 5 subjects marks from the student, okay, and then print his percentage and grades. His marks are out of 100, okay, and the code for doing that is code by rule. The code is that if he has got 80% or above, then it's A grade. If he has got 60% to less than 80%, then it's print. You should print B grade. If it's 40% to less than 60%, then it's C grade. And if it is less than 40%, then not fit for technical education, NFT. Or you should print D grade basically, not NFT. Yeah. Just attempt this. Okay. I hope you guys would have taken some attempt in some form or other. I'll write it for those who were finding it difficult. Okay. See, but there is a possibility of typecasting error here. Okay, so I'll just show it to you. For example, if some of you have taken the inputs as integer A, B, C, D, E. Okay, it's okay. You can take scanf statement use kar lena and take the inputs. Okay, I think you guys can do that easily. Now, what you would have done is, for example, don't put semicolon here. You would have created a variable percent. If you create a variable percentage, okay, of course that percentage variable will be float PER. Okay, now if you have done it like this, is it right or is there any mistake in this line? Wrong. Yes, because 5.0. Yes, it should be 5.0. Otherwise, all these integers divided by 5 integer, you will get the percentage and you can lose some value. Okay, therefore either take all these variables in float, or if you have taken them in integer, it's okay, but make it 5.0. Correct. Yes. Now once you have calculated the percentage, see here you can also do one thing. You can make a variable called char g for grade. Okay, and then we can write a statement like this, that if percentage is greater than equal to 80, then G is equal to A. Else if percentage is less than 80 and percentage is, now here you should not get confused between and or. Okay, we have to use and here because if you use or, then it will cause errors. If anyone has doubt in that, then you can tell me. Greater than equal to 60, then it will be G equals to grade B. Okay, see, if you use or here, then it will be problem, because even if the grade is like 40, okay, so plus it is less than 80, then it will become true, and if you use or here, then it will be, the statement will be true and the grade will be B. So it is less, it should be less than 80 and greater than equal to 60, then only it will be in that range which we want to check. Okay, the next statement will be like this, something like, else if percentage is less than 60 and percentage is greater than equal to 40, then G is equal to C. Don't forget to put single quotes. Else G is equal to, yeah, D. Okay, and then you can, of course, then you can go on and print the G. Now note that I have not used curly brackets anywhere. Do you see? I have not written it like this. See, I could have done that, but there is only one statement in this condition. So even if you don't put curly bracket, the next statement is considered a part of that if statement. Okay, because the semicolon is coming here. So until that semicolon comes, this entire thing is actually one statement. You could have also written G equals to A here. Okay. So if there were more than one statement, then I would have used curly brackets, but since they are not, so I'm not using. But you can put that, there's no error in that. Okay. I hope it is clear to everyone. Yes. Now we are done with if else. Now we'll move to another conditional statements called switch case. Okay. See, this is also a conditional statement. First, I'll tell you the syntax and then I'll tell you how it works. But there are some limitations to it. There's a condition which comes here. In fact, it's not a condition, it's an expression. Oh, sorry. Yeah. And then we write it like this. For example, case 1. Then there are some statements. Then there's break. I'll tell you what it means, don't worry. Then there's case 2. Break. Then there can be more cases, and or else you can put default. Okay. So yeah. And then we can close the curly. See, what it does is there are two limitations to switch case. First limitation is that it can only check equality. Means whether something is equal or not. It cannot check greater than, less than. So we don't have the flexibility which we had in if else. The next limitation is that it can only work with int and char, no other data type. So now see what happens is, for example, there is a variable called int c. Instead of this expression here, I'm writing c here. So c becomes our the main control variable. Now the value of c will be matched with the different cases. Okay. Now assume that I put the value of c equals to 2. So first the compiler goes here, case 1. So is c equals to 1? It checks double equals to 1. This is the equality condition that is checked. It can only check c whether c is equal to 1 or not. It cannot check greater than, less than. That is not possible. So if c is equal to 1, then these statements will be executed. I'll tell you about break. Now, but c is not equal to 1 because we know that c equals to 2. So it checks the second condition, case 2. Is c equals to 2? Yes, c equals to 2. So these conditions will be executed, which you write here. Okay. And you don't need to put curly braces here. Now assume that c is equal to 3, which is not any case. So if none of the cases match, then default case is executed. Okay. Now remember two things. It's not necessary to write default condition, default case. You can omit it as well. Okay, it's only written as a backup. For example, if someone gives a wrong error, so you can print it that your error is not your input is not acceptable. Or and default need not be at the end. You can also write default in the beginning. The compiler will search for the default, and if it finds anywhere within these curly braces, then it will execute the default. It's not that if you write it in the beginning, the default will be executed first. No. In fact, you can write the cases in any order. Now let's come to break. See, break is basically a jump statement. We'll read more about them in detail, but for now, let me just tell you that if you don't write break, something will happen which is technically called fall through. So what will happen is, if you don't write break here, no? So assume that c equals to 1. So as soon as this condition is true, then the compiler comes here, the control comes here. Okay. Now after this, the control does not come out of this loop on its own. Okay. So if there is no break here, the control will execute this line, it will execute this line, it will also execute this line, this line, this line, and when it when it is encounters break statement, only then will it come out of the loop. It will come out of the loop, it will come out of the switch case. So break is used to break the loop which is going on, the repetition that is going on, it completely breaks that cycle and comes out of the statement. Okay, so if you don't put break, the fall through happens. The statements which you didn't want to get executed, they will also get executed. This happens in switch case. Okay, sometimes fall through is used in some programs, but most of the times it can lead to some logical errors, so remember to put break there. Now let's write a simple program. Try to write a program. Write a program to build a simple calculator. Using switch case, of course. Calculator which can do plus, minus, multiplication, division. The user will give input like this. They will give an operand, then the operator, and then another operand. For example, they can give input like this, 5 into 2. So your output should be 10. If they give 5 plus 2, then your output should be 7. So there are 3 inputs to be taken from the user, and depending on that, you should reproduce the output. Yeah. Give an attempt to this question, guys. Yes. Okay. So let's try to do this program. I hope some of you must have tried this. Okay. See, the operands can be decimals also, so it's to be on the safer side. I'm taking float a comma b. Okay. Then I'm creating one char ch for storing the operator sign. Okay. Then I'm giving a print, which we can give the printer statement. Enter operand 1, operator, then operand 2. Operand is the variable on which the operator works. Okay. Then we can use scanf, percentage f, percentage c. See, I've used character because character and integers can only be used with switch case. Percentage c and a. Be careful here. This should be and ch next, and b. If you write and a and b and ch, then everything will get messed up. Okay. Now, which is my control variable? It is ch, because this is where the operand is getting stored. Now I'll put a big curly bracket here. Now what is first case? See, since it's a character, it cannot be case 1, it will be case plus, and of course in single quotes. So when it is plus, now let us create one variable for storing the result, because we don't want to do printf every time. So here let us create one more variable, result, res. Okay. So let's use that result variable. Res is equal to a plus b. Then break. Similarly, we'll do with case minus res is equal to a minus b. Then again break. Case multiplication, res is equal to a into b. Then again break. Then we can write case division, res is equal to a divided by b. Break. Now there's also a default case. Instead of writing it there, I'm writing it here just to make it a point that you can write the default case anywhere. Okay. Default case is if the operator doesn't match with any of these, then we can print invalid operator, because our calculator is not designed for this your operator. Okay, but you should put a break here then, because if this statement gets executed, then if you don't put a break, then these statements will also get executed, this statement, and we don't want that. Okay, so if you are not using the default in the end, then you will need to give a break. Then you can avoid this break, because this is the last condition, so you don't need a break here. There is no possibility of fall through happening there. Okay, then we can print it. Printf result. Our result variable was a float, so yes. So this is a program for a simple calculator. Okay, I hope it is clear to everyone. See, you've written a program for simple calculator. Okay, so this brings us to the end of conditional statements. We'll be using them more in the future programs, but for now, I think these many examples are enough. Now we come to a very important part called loop. This is very interesting. Interprogramming is interesting in itself. Okay. See, one of the very first reasons why humans developed computers and programs was that we get bored. We don't like to do one thing again and again. For example, we did a program where you had to take inputs of the 5 subjects of a student, and then you had to calculate the percentage and grade. Now assume you are a class teacher and there are 60 students in your class. Okay, then wouldn't it be very tedious to write the program again and again, for all those 60 students? So we want something that with the same program, with the same amount of code, we can do the same thing again and again 60 times. Okay, so that is where a loop helps us. The technical meaning of a loop is when you get stuck in a loop, like many of you will get stuck in the loop of engineering classes. So yeah, so this is the basic meaning of a loop, and we'll execute it using, two kinds of famous loops. One is the for loop and one is the while loop. Okay, a while may, do while is also there, so you can add that, but it's basically the same thing, almost the same thing. For loop and while do while loop. Okay, see, there's a very subtle difference in why we have two kinds of loops. See, for loop is generally when we have to run the loop for a fixed number of times. We know that, okay, these many number of times mathematically we know, and we have to run the loop for those many times. But while are used generally when you have to execute a program until some condition is true, or maybe until the user wants it. So there's a very basic syntax. For, then we initialize the variable, then there's a test condition, and then there is update statement. Okay, and then there are some line blocks of code. Okay, so see how it works. Initialization, test condition, and update. See, whenever the program starts, the control reaches the for loop, first some variable is initialized, okay, with the statement that you are given. I've already explained what initialization is. Then it goes to the test condition. It checks whether the condition is true. Okay, if it is true, then it enters the loop. These statements are executed. When the statements get over, then it goes to the update, where this variable which you initialized here is updated. Once it is updated, it again checks the test condition, whether the condition is true or not. Now if it is still true, then it again executes these statements. Then it again goes to the update, and this cycle will continue till the test condition is false. When the test condition is false, the control will come out of the loop. Okay. Now sometimes what happens, due to some logical error, for example, if you don't update your variable, now if you don't change the variable, then once the test condition is true, it will always remain true. Then this loop will execute for an infinite number of times, so it is called an infinite loop. Okay. This can sometimes get your system struck. So this is what was the control flow which we can understand. Let me show it to you by a simple example. For int I is equal to 1. See, I am creating I here and I'm initializing it also in the same line. You could also have created it beforehand and then you could only use I equal to 1 here. For example, int I created before and then here I only write I equals to 1. So both of them is correct. I less than equal to 5, I plus plus. Okay, then printf hello. So, and with hello, maybe I should put a line change. Yes. So now what will happen? See, I equals to 1. Is 1 less than 5? Yes, true. So since 1 is less than 5, the control comes here and prints hello once. Hello. Line change. Line is changed. Then it goes here, I plus plus. So now what is the value of I? I equals to 2. Now, is I 2 less than 5? Yes. So it again comes here and prints hello once more. Now again it goes there, it updates it to 3. 3 less than 5, yes. 4 less than 5, yes. 5 less than equal to 5, yes. When the control goes there again and it becomes 6. Now when it checks 6 less than equal to 5, no. So it comes out of the loop. So it basically prints hello 5 times. Now since you guys have understood it, tell me what will be printed if I write it like this. For int I equals to 2, I less than equal to 7, I equals to I plus 2. Printf hello. How many times will it be printed? 3 times. Everyone is clear? Yes. For I equals to 2, for I equals to 4, and for I equals to 6. When I equals to 8, then the control comes out. I have not used curly brackets here because there is only one statement. Okay. Now you're ready for some interesting programs. You can take out your notebooks again. Write a program to just start with a simple series. Print this series. 1, 2, 4, 8, 16, 32, 64, 128, 256. Of course, you know what I'm doing. But you have to print this series using a for loop. It's a very simple program. Just try to do it quickly. Yes. I hope you guys would have taken an attempt. It's very simple, but still I'll just show it to you. So it can be done actually in many ways. Okay. For example, I first create a variable int I. For I is equal to 1. That is one way of doing it. It is actually a good way, so I'll show it by that way only. Okay. Yes. So what happens first? I equals to 1, so we need to print it. So we printf %d, and we put a comma here if you need a comma, and then I. Okay. So after this, the I gets multiplied by 2. Then it again checks this condition. This gets printed. Okay. Can you do it if I put a constraint on the update statement? If I say that it can only be I equals to I plus 1, can you do this program now? You can change anything else, but I put a constraint that can only be I equals to I plus 1. See, here you chose your own update statement, right? Now I have fixed the update statement. It can only be I equals to I plus 1, that is I plus plus. Now change the for loop in such a way that still you get the same output. You can change anything else, only this statement is fixed here. So there are many ways to do it. Okay, one way is then which everyone is giving. I'll start with that only. For I equals to 0, I less than equal to 10. Okay, and I plus plus. Hold a second. We're going to go 10. Yes. Okay, fine. So then we can printf percentage d. Sorry, and 2 power I. Okay, so this will be printed and it will give you the entire series. I hope it is clear to everyone. Okay, can you try to attempt another question? Write a program to enter 1000 numbers and print the smallest number out of these all those numbers, and you have to take these inputs from the user. Okay guys, let's try this question. Okay, see, we have to take 1000 numbers, so it's very clear that of course we have to use a loop, but we have to print the smallest number. Okay, now what can be the best way to do this? The best way can be that, see, even if assume that there are 5 numbers, okay, and the numbers are coming one by one because the user is entering them. What we can do is we can store the first number, okay, somewhere. When the second number comes, we can compare this stored number with the second number. If the second number is smaller than the first number, then we can store the second number in this place. Now if the third number comes, so we can compare the third number with this place. Okay, means this is the place where we always update the smallest number. Okay, we create a memory location and we always update the smallest number, and we check every time a new number is coming up. Okay, so this can be done in a way. First of all, let's take one number input, scanf. I'm not writing the printf statement. I hope you guys understand that. Okay, n, sorry, and n. Okay, n has already been declared and printf has been written to enter a number. So n is we have n here. Now int small equals to n. So this small is our location where we have stored n, because we have only got one number, so that is our smallest number for now. Okay. Now look carefully. Now how many more numbers we need to take input of? 999. So we'll create a loop. Int I equals to 1. I less than equal to 999. I plus plus. Okay. Now printf enter a number. Now see, this printf statement will be printed 999 times. Scanf and n. See, I'm using the same n variable because once I've used that n, I don't need the value of that n. So I can discard it and store a new value in that same memory address. Okay. Now, if this n, this second number which has been inputted, if it is less than our first number, where have we stored our first number? In the variable small. Then small is equal to n. Is this statement clear to everyone? Because this is the crux of this program. If the new input number is smaller than our earlier version of the smallest number, then thus we update the value. Yes. See. Okay, let me write the program and I'll show you. The program almost ends here and we printf percentage d small. Now let me show it to you. One problem is that I can't show the full program in one screen. Okay. See, for example, the first number you enter is 5. Okay, 50. So what is the value of small now? 50. Now we enter this loop I equals to 1, which is true. So first again you get a statement, enter a number. You enter 70. Now it is checked. Is 70 greater less than 50? See, what is the value of small here? 50. Now the second number that you entered is 70. So is 70 less than 50? No. So the value of small is not updated. This statement is not executed. Now we go to the next iteration. Again, it asks you to enter a number. Now this time you enter 30. Okay. Forget 70. Okay. Now this time you have entered 30. Now what is the value of n? N is 30. So is 30 less than small? What is this value of small? It is 50. If 30 is less than 50, which is true. So this statement is executed now. So small is equal to 30. So now what is the value of small? 30. Now again next number is inputted. So this will keep on continuing and the smallest number will get stored in this variable, which we print in the end. I'm not writing all these in the online compiler, but I hope you know the basic thing is to understanding the algorithm. And if you understand that, you can try that if anywhere, online compiler, VS Code editor, wherever you want. Though I prefer online compiler always. Yeah. A very simple question, write a program to enter a number and print its factorial. I hope you know what is factorial. I'll tell you. But you have to take an number from the user and then print its factorial. Yes, it's a simple question. I'll tell it to you. Int I is equal to int I. Sorry, then you can take an input scanf percentage d and n. Okay, then for I equals to n, I greater than equal to 1, I minus minus. Okay, you can also instead of ending it here, f is equal to f into I. Then you can print this f here. Just print this f. I hope it is clear. Okay. There are some interesting pattern questions that can come. Write a program to print this pattern. This is an interesting question. To print this pattern. I want this pattern to be printed. Yes, guys, take an attempt. Yeah, I'll just show it to you how we can do this. There can be different ways. It's not limited to what I'm doing it here. Okay. See, I can start with for int I equals to 1, I less than equal to 5. If you find that you can do it with some other way also, you can maybe you can maybe show it to me, or you can go and check your method in online compiler. Okay, I plus plus. Then I write for int j equals to 1. See, the reason why I'm doing it like this is, let's first develop a logic rather than going to the program. See, do you see the ending number? What is happening that in every line, it's starting from 1, but it is going to the number of the line. For example, this is the first line. This is the second line. This is the third line. This is the fourth line. This is the fifth line. In the fourth line, we are printing from 1 till 4. In the fifth line, we are printing from 1 till 5. So the numbering of the line is done by I. I is varying from 1 till 5 because there are 5 lines. And we are using another variable j, which will vary from 1 till the numbering of that line. And what is that numbering of that line? It is stored in I. So it will vary from 1 to I. See, I will vary from 1 to 5 and j will vary from 1 to I. Now let us implement this. I hope you can see I is equal to 1 to 5, j equals to 1, j is less than equal to I, j plus plus. Now we are printing j here. See, many times people get confused in the print also. When j varies from 1 to I, okay, basically we are printing j, 1, 2, 3, okay. So printf percentage d j. Just take a moment to absorb this. Is it clear to everyone how this nested for loop is working? If anyone has any doubt, you can ask. You can attempt some questions. Like for example, you can try to print this pattern. 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5. Then you can attempt something like what can I say? Yeah, you can attempt 1, 2, 3. You can note down the questions. You can attempt it as a simple homework. We'll discuss it into 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So I'll really like it if you guys can take an attempt at these questions. Okay. It will be fun, believe me. Take an attempt